Welcome to News Channel 5. I'm Nina Koch, and I have an amazing program for you watchers today. Today we are exploring the world of electromagnetic waves, and more specifically ultraviolet waves, the best kind of waves. So are you ready to learn about the mysterious light that you can't see? First, we need to look at some general terms used when talked about.
Radiant energy or radiation is energy that is transmitted in the form of electromagnetic radiation and energy that exists in the absence of matter.
Light or visible light is electromagnetic radiation that can produce a visual sensation.
A photon is the name given to a particle of light or other electromagnetic radiation.
Electromagnetic waves are radiation consisting of waves of energy associated with electric and magnetic fields resulting from the acceleration of an electric charge.
The electromagnetic spectrum is a range of electromagnetic waves extending from radio waves to gamma rays.
Now that you know some general terms, let's talk more specifically about electromagnetic light. The first thing we need to talk about is the electromagnetic spectrum. The electromagnetic spectrum is a scale that shows a range of different electromagnetic waves that are made up of different frequencies. On one end of the scale are waves with low frequencies, and on the other ends are waves with high frequencies. Most of these waves are too high or low to see. Another thing that is essential to know is how electromagnetic waves are generated. They are created from an electric field and magnetic field couple. When a charged particle becomes accelerated, it becomes electromagnetic radiation. This also happens when the electrons jump from a high energy state to a lower energy state and produces radiation. Wow, that's kind of confusing for me. Why don't we go to our resident expert, Margaret Burke. Margaret, you can help us understand about electromagnetic light, right?
Of course I can, Nina. First of all, electromagnetic waves are very fast. They travel through space at about 300,000 kilometers per second. That's 300 million meters per second. Light travels faster than anything in the universe. Waves do not behave like waves. Sometimes they behave like particles. This is called the photoelectric effect. The photoelectric effect is the removal of electrons from certain materials when light falls on them. The metals that this happens to are called photosensitive or sensitive to light. High-frequency light shine on photosensitive surfaces can remove electrons, but a low-sensitive light cannot. If the energy of the photon from the light carries enough energy, the electron will be removed. Basically, it is the flow of electric current through a vacuum or a material when the material is exposed to light.
Wow, Margaret, that is very interesting. I guess light breaks the rules sometimes. But tell me, how does frequency, wavelength, and energy behave in the electromagnetic spectrum?
Oops. Sorry, I was just looking into that light for ultraviolet light.
Oh, Margaret, you always do that. Don't you know that you can't see ultraviolet light with the human eye?
Oh yeah, of course I do. It just slipped my mind. You see, frequency, wavelength, and energy are different for each type of wave. On the left end of the spectrum, the waves have a smaller frequency, a longer wavelength, and less energy. I guess you could say they're lazy waves. On the right end of the spectrum, the waves have a bigger frequency, shorter wavelength, and more energy. These waves are on caffeine. Ha ha ha.
Are all waves electromagnetic waves? That would be kind of boring.
Of course not. There are electromagnetic waves and mechanical waves. Both can travel through the mediums of solid, liquid, and gas. However, they are very different. Mechanical waves need a medium to travel through. The ripples made in a liquid when a stone is thrown in water are mechanical waves. The disturbance occurring is called a periodic disturbance. Another name for mechanical waves is elastic waves because the amount of elasticity depends on the medium it travels through. Mechanical waves can be divided into three types of waves: transverse, longitudinal, and surface waves, and they are caused by the amplitude, not the frequency. Electromagnetic waves can travel through anything, even space and a vacuum. Electromagnetic waves are forms of visible light, visible radio, X-rays, ultraviolet, infrared, and microwaves. They are produced by the vibration of charged particles.
Thank you, Margaret, for all the fascinating facts about light. However, I think that our watchers would be interested in ultraviolet light. Let's go to our expert on UV light, Nikki. Hi, Nikki. How are you?
Hi, Nina. Thanks for having me. I'm super excited to be here. Woohoo! Ultraviolet light has its own special frequency, range, wavelength range, and energy range. Frequency range is 7.5 times 10 to the 14th through 3 times 10 to the 16th hertz. The wavelength range is 400 nanometers through 10 nanometers. The energy level range is 3.1 electron volts through 124 electron volts. That's what makes it so special. Woohoo! The biggest source of ultraviolet rays is the sun. Other man-made sources are UV lamps, arc welding, and mercury vapor lamps. UV rays are used in medical and dental purposes. It kills bacteria, creates fluorescent effects, phototherapy, and suntanning. Woohoo! You have to be careful though because UV rays can cause skin cancer and have other negative effects on the body. Woohoo!
Wow, Nikki, you are so excited about UV light.
Sorry, I just really care for it and deeply in my heart.
Why don't we hear some fun facts about UV light?
Bees can see ultraviolet light. Psst. Too much exposure to UV radiation can cause skin cancer. Ow! Some things that are not visible to the human eye can become visible under UV light.
UV light is 1,000 times more present at the equator than at the poles, so marine life at the equator are better adapted to UV lights than those who live the north and south poles. That's why fishes have better tans at the equator.
UV rays cause color to fade over time. UV traps are used to kill small flying insects. UV light kills all the bacteria and viruses.
Well, now you know all about UV light. Thank you for joining us for this breaking news presentation. I'm Nina Koch, signing off. Oh.
Restart it.
Oops. Oh no, I messed up. I'm so sorry. Oops.
You threw it on the desk.
You didn't come up and down.
It hit the desk. How is there? There's no way.
Nikki! Oops, you Oops. Sorry.
Oh, Margaret, you always do. Okay, that was the best one yet.
Okay, but I just said I have to talk first.
Too much exposure to the UV radiation can cause skin. I messed it up. Stop it. Too much exposure to UV radiation can cause skin cancer. Zzz.
Why are you... Okay. Welcome to News Channel 5. I'm Nina Koch and I have an amazing program for you watchers tonight. Today we are exploring the world of electromagnetic waves, and more specifically, ultraviolet waves. The best kind of waves. Nikki, what are you doing?
Second.